This is part 3 of a 1 hour and 40 minute recorded Twitch stream from the 16th of April 2020, where we discuss the various MPLS VPN building blocks from a design perspective. In this session, we will explore the core. We will validate an MPLS VPN design focusing on the core network, configuration and various prerequisites that have to be in place prior to setting up PE to CE connectivity for customers. We hope you enjoy the video, and if you do, please let us know by providing a like, comment or telling anyone you know who may be interested. Thank you. A very small MPLS network here, right? That's what we have on the left hand side is 2 CE routers. We've only configured this CE, so CSR5, XRV1, 2, 3, 4. And how that looks is XRV1 and XRV4 are provider edge routers, XRV3 is a root reflector, and XRV2 is a P node. So what I want to do is first of all show you the configuration on the PE nodes, and I'll work through the stack. So I'll show you the loopback configuration, then the OSPF configuration, then the LDP configuration, then VPN v4 and VPN v6 and how they peer to the root reflector, and then we'll have a quick look at the root reflector and the P node and see if we can tie it all together. And we've done a bit of configuration on this CSR5 as well. And just so that you know, the P and the PE nodes are all XRV. The CE nodes are all iOS XE, so the configurations will be slightly different between the two platforms. So what we'll do is we'll start on XRV1, and we have that here. So if I log into XRV1, and the first thing that we're going to do is we're going to figure our way around the network. So if I do a show IPv4 interface brief, you'll see that we have a few interfaces configured here. So the one that we're interested in that faces the core network is gig 0000, which is this one here. Now if we look at the show run in gig 0000, you see it's a very basic configuration. It's got an IP address on it. It's in the global routing table. Okay. The other interface that I don't think I've actually got a loopback. Have I got a loopback in here? Oh yeah, no, sorry, I do have a loopback interface, and it's always loopback 0 that I've got on all of the devices. And that's 1.1.1.1. So if I do show run in loopback 0, you'll see it's a very basic configuration in the global routing table, and it is advertised. Sorry, well, we've not got that far yet, but it's it's 1.1.1.1. It's in the global routing table, no VRFs, right? So if we then go to the next stage, so now if we go back, back to our diagram. Let me see if I can bring that into the mix. If we go back to the diagram, so loopbacks isn't even listed there. So let's move to the OSPF. I've got OSPF 100 there, but the best way to figure out is or to kind of see what you've got running is show protocols, and then it will show you that you can narrow that down to, this is in iOS XR. So if you do show protocols OSPF, you can see that the OSPF process is OSPF1, the router IDs using the loopback, all that kind of thing. The interfaces in area 0 or loopback 0. I've not actually made that passive yet, so I probably should have, but anyway, we have that. So the next thing that I would do is I would do show, it's just some verification command, show SPF interface brief, and then that just confirms what we already seen in the show protocols. If you want to then dig a bit deeper, you can do show run router OSPF. You see the configuration for XR, and you can also obviously do show OSPF database and things like that. So you can see here that in the OSPF database we have 1.1.1.1, 2.2.2.2, all the 3s and all the 4s, and that effectively is the loopback interfaces which are advertised from XRV 1, 2, 3 and 4 that we will use to peer LDP. So if we go back, let me see if I can get the video back. So we've verified that we've got loopbacks. We've verified that they're running in OSPF on the PE node. The next thing in the stack is we want to verify that we've got label switching enabled. So show MPLS LDP forwarding. We can see that we've got some form of label database. We've not really got time to go into the ins and outs of what all this means, so I'm giving you some commands that you can leverage just to verify things are up and running. Show MPLS LDP neighbors. I think there's a brief command as well. So you can see here that the neighbor, my neighbor is 2.2.2.2. So I'm on XRV1, and then I've only got one interface running in LDP. So I would expect that to be this device, which we'll verify in a minute, but it looks good. So we've got an LDP neighborship. We've got loopbacks configured 1.1.1.1, etc. And we can see that we're actually peered to 2.2.2.2. If we then move to the next part of the verification and see how the things are built up. So back to the diagram, the next thing in the stack is VPN v4 and VPN v6 iBGP. So we can start off with something basic like show BGP VPN v4 unicast summary, which shows that we have neighbor 3.3.3.3. Now, just from the design documentation, and this is where it comes back to the design and making things easy to understand. So if you know that like a loop back for on a device is always going to end in like the last octet is always going to be the number of the router number, right? So if you look in my diagram, you've got XRV3. So I'm peering to 3.3.3.3, and this is a very simple network, but I look at that immediately and I think, right, I'm peering BGP to XRV3. So I know that there's a session up for IPv4, BGP IPv4 unicast. If I'm in, or VPN v4 unicast, sorry. If I'm interested to see if IPv6 is running over the MPLS network, I might do the same command and then see that you notice here that I'm doing show BGP VPN v6 unicast summary. But if you look at the neighbor, I'm peering over an IPv4 address. And that leads us into having a look at the BGP configuration. So if I do show run router BGP, there's a couple of things that we want to look at here in this configuration. We have the BGP router ID, which is defined, so that we want to make that deterministic. I think it's compulsory in iOS XR. But anyway, we then have to, in the BGP process, enable the address families that we want to use throughout the rest of the BGP configuration. And where that is then used is effectively underneath, you define a neighbor, so it's almost like reverse logic than iOS. but you define a neighbor. So say neighbor 3. We say, so this, what we're doing here, because it took me a little bit of time to get my head around this when I was looking at it initially. But what we're doing here from a config perspective, I know this is a design session, but it's just little things to be aware of. What we're doing here is we're asking this iOS XR box if, or we're telling it that throughout the rest of the BGP configuration, we might want to use IPv4 unicast, VPN v4 unicast, or VPN v6 unicast, and and that's, so that sets us up nicely for the rest of the configuration. We then go into the neighbor syntax. So this is now like, so I'm in BGP Autonomous System 1, and then I'm going under a neighbor, then I say remote AS1. So that tells us that we are peering iBGP internal BGP to 3.3.3.3, which we know is XRv3, and then we're using the update source as loopback 0, which we know is 1.1.1.1 in this box. And then what we're saying is under this neighbor, we want to peer to 3.3.3.3 with a VPN v4 unicast session and a VPN v6 unicast session. So that's what that's doing, is it's preparing all this stuff that you see in the thick blue line and the thick green line. It's what we've used here is the purple, the really skinny purple loopbacks that I drew in to peer. Well, OSPF is running, right? And then we use the loopbacks that we advertise into OSPF to then peer with our neighbours for LDP. Once we have LDP up, we then peer to the route reflector via the green line for VPN v4 and VPN v6. And that is ultimately preparing us in the core of the network and getting us ready so that we can then peer this way out to our customer. And there's a couple of steps before that, before we can do that, which I'll talk about in this config too. So you see here, so if you look at this config, it's only a few lines of code, but that's from the PE perspective. If we move over to XR3, which is our route reflector, and we do show BGP VPN v4 unicast summary, we see that we actually have two neighbours here. One of them is 1.1.1.1 and one of them is 4.4.4.4, and that is the two PE nodes, which are here is PE4 and here is PE1. And we see that we've got like one prefix being learned from there. So if we look show run router BGP on this box, it's quite a similar configuration, really. So the only difference that we see is we've got the neighbor defined, we've got the iBGP configuration, we set the update source to be loopback 0, and then we say that we want to use this neighbor in VPN v4 unicast. The additional piece of code that is in this is we define route reflector client underneath VPN v4, and then we define route reflector client underneath VPN v6. When we're defining route reflectors, if you don't know, in order to make something a route reflector client, you only need to change it on the peering of the route reflector. You'll probably know this if you've done like some basic BGP stuff, but this is just showing you it in action, because you'll probably have done it for IPv4. But it's exactly the same logic in an MPLS network, where it's the same commands. So if I was making this an IPv4 network, it would be the same logic. You would go under the neighbour, define the AS, set the loopback 0 as the update source, and then you go under the address family IPv4 unicast, and then do root reflector client. So it's a similar kind of process is what I'm trying to get across. So from a design perspective, a BGP design perspective, this design that we've got on the screen here, you know, it's pretty similar for anything that you're wanting to run IP on. So whether that's over or IPv6, yeah. But yeah, you see that the purple devices in this BGP peering are completely transparent. They don't take part in BGP at all. This concludes part 3 of MPLS VPN building blocks. Please click the link in the description for part 4, where we will take a deeper dive into configuring PE to CE links and multiple VRFs, using a small MPLS lab to provide explanation and validation of the design.